In this lesson, we're going to be talking about compound probabilities. A compound event combines two or more events using the word and or the word or. Compound events can be mutually exclusive or they can be overlapping. Mutually exclusive events are two or more events that cannot happen at the same time. They have no common outcomes. The formula for mutually exclusive events is the probability of A or B equals the probability of A plus the probability of B. You could also see this as probability of A union B equals probability of A plus probability of B. For overlapping events, these are two or more events that can happen at the same time. They have at least one common outcome. The formula for overlapping events, probability of A or B, is equal to the probability of A plus the probability of B minus the intersection of the two, probability of A intersect B. So again, you could see this or replaced with the union symbol on either of these formulas. So let's talk for a minute just about what it means for two events to be mutually exclusive versus overlapping. Mutually exclusive just means that there are no common outcomes. For example, I have defined group A to be students in my third period class, and I have defined group B to be my students in my fourth period class, and there are no students that are in both classes at the same time. So A and B are mutually exclusive. As opposed to the second scenario that I have here, students in group A are students in my third period class. Students in group C are students who have dogs. Now, there are probably some students who are in third period and have no dog, and there are probably some students who are in third period and have a dog, and there are probably some students that have dogs, but they're not in my third period. So we have this overlap here in between, and if I was to count all of the students in all of these categories, I wouldn't want to count those students in the overlap twice. And that's why the overlapping formula subtracts out the overlap between the two groups. Let's try an example. When rolling two dice, find the probability that the dice will have a sum of 4 or 5. So with a compound event like this is similar to the heads and tails scenario we saw on day 1. We're rolling two die simultaneously. And so we want to create a table that shows both of those events happening and how they can combine together. So I'm going to make a table, and on each side of the table I'm going to represent die 1 and die 2 and the possible outcomes that can happen for each of those dice. And since this problem is asking about the sum of the pairs of dice, I'll write the sum of the pair of numbers on each side in the boxes. So if I roll a pair of 1s, the sum would be 2. If I roll a 2 and a 1, I would get 3. And then I'll just continue to complete the sum for each pair of numbers in the table until it's complete. Now, we've been asked to find the probability that the sum will be 4 or 5. So in our little table here, we can see that there are 1, 2, 3 sums of 4. So the probability of getting a sum of 4 is 3 out of 36 total possible outcomes. There's 6 for the first die, and there's 6 for the second die, and so that's 36 total possible outcomes. And then we'll add the probability for the sum of 5. 1, 2, 3, 4. There are 4 ways that the sum could come out to be 5. And these are mutually exclusive events, meaning that there is no way that you could have a sum of 4 and a sum of 5 at the same time. We do not have to subtract any overlap because there is no overlap to subtract. So we'll add these two probabilities together, and that gives us 7 out of 36, which does not simplify. In this next example, we're going to use the chart at the right, which details a survey of girls who responded about their favorite store. The first one, we're asked to determine the probability that a girl has responded that either Macy's or Nordstrom is her favorite store. So here's our Macy's, and here's our Nordstrom. And there's no overlap, so we don't have to subtract anything, and that gives us 0.45. Now, if you notice, when I add all of these numbers in this chart, the total of this is 1.00, which represents 100% of the people who responded. For the next probability, we're asked to find the probability that a girl from the survey has responded her favorite store is not JCPenney's. So basically that's everyone except the people who chose JCPenney. So this is the probability of JCPenney complement. A shortcut for this is to just take the 1 that represents all of the probabilities in the table and subtract the JCPenney probability, which gives us 0.90. In example 3, we're finding the probability of choosing a card from a deck, and it's a queen or an ace. So there are no cards that are both ace and queen at the same time. So again, this is mutually exclusive. So the number of queens in a deck of cards is 4 out of 52 total cards. And if you're not familiar with a deck of cards, we posted a reference sheet, and that is super helpful to you. It has the rolling of the dice, it has a deck of cards, and it has some Venn diagram set notation things on it for you to use. So you probably want to print that out and have that with you as you're working. So there are 4 queens, and then there are also 4 aces out of 52, and that gives us 8 out of 52 for our probability. And then we'll want to simplify that to 2 out of 13. In example 4, we're given a Venn diagram about coffee and soda drinkers. The first question asks, what is the probability that a person from the survey will drink coffee or soda? So remember that OR is the union of the two groups. So group A is the coffee drinkers, group B is the soda drinkers, and then of course you have your overlap in between. But the union includes all of those parts of all of those groups, and so we'll add those 3 together. 31 plus 12 plus 25. Now we're writing a probability, so we need a denominator for this probability. We need to find the total for the sample space, which includes all of the office workers surveyed. So we'll add 31, 12, 25, and 83 to get the total number of office workers, 151. So that will be the denominator for our probability. So we'll add 31, 12, and 25 to get 68 out of 151 for the probability that the person would drink coffee or soda. Then it says how many people drink coffee. So the number of people who drink coffee, that's everybody in group A. So 31 plus 12, that's 43 people who drink coffee. This question says how many drink soda, and so that'll be all of the people in group B, which is 12 plus 25, so that's 37 people. And finally, how many drink both? We're looking at just the people in the overlap, so 12 people drink both. For this next example, we also have a Venn diagram, but let's use the formula that we've been given and see if we get the expected result. So to find the probability of A union B, remember that union is another way of saying OR. And so for A union B, we're going to find the probability of A plus the probability of B minus the probability of A intersect B. And this again is the overlap. So the probability of A we want to find all the total number of students for A, and that's 125 out of the total number of students in the table. So we need to calculate the total. So 160 plus 35 plus 530 plus this 475 that is neither in the band nor in the club, 475, the total students is 1,200. So our denominator here will be 1,200. The probability of B, that's everybody that's in group B. So that's 530 plus 35, which is 565 out of 1,200. And then we'll subtract the overlap between them, which is that 35 in the middle. So we'll add those and then subtract, and our final answer will be 725 out of 1,200, which simplifies to 29 over 48. Now let's see if this makes sense with what we did in the last problem. We found probability of A union B in the previous problem. We just added everything in both groups because union means either or. We can find the total of all of the things inside either group. So 160 plus 35 plus 530 equals 725 out of 1,200. So we get the same result, and when we have a Venn diagram, it's a little bit easier to visualize that overlap. But this just illustrates a little further why we are subtracting that overlapping part. We counted the overlap with both group A and then again with group B. And so that overlapping part got counted twice. So we had to subtract one of those times out of there to cancel that out. So what does this mean? If A is band members and B is club members, this means that if we randomly chose a student from Lewis High School, the probability that that student would participate in either band, club, or both is 29 out of 48. So out of every 48 students in the school, 29 of them participate in one of these activities. In example 6, we're finding the probability of drawing a card from a standard deck and getting a king or a club. So there are 4 kings in a standard deck of cards and there are 13 clubs, but there is one that is a king of clubs. So we will use our overlapping formula. So we're going to do probability of king plus probability of club minus probability of king intersect club. So our kings, 4 out of 52. Our clubs, 13 out of 52. And then we'll subtract the 1 that is both a king and a club. And that gives us 16 out of 52, which is 4 out of 13. Watch part 2 of this video to complete the notes for the lesson.